So today what we're looking at is the sine law. So just a review of the sine law. Okay, first of all, it works for non-right triangles. It actually works for right triangles too. And one thing that we need to remember that we label our angles with capital letters and the angles directly across with the lowercase of the angle letter. Okay, so two different versions of it. Although some teachers will say you use the one version to find the side length, use the other version to find the angle. Actually, you can, because you're very good at manipulating formulas, it really doesn't matter which one version of it you use. So when it comes to examples, I'll use both. I'll just interchange so that you can see that it works. Okay, so the way the sine law works is sine of the angle A over its side length equals the sine of the angle B, another angle in that triangle, over its side length. And finally, sine of the C over its side length. So the one version of the formula is like this. The other version has it just flipped around. Okay, so it has the inverse of it. And amazing, it doesn't want to show me. But that's all right. I'm sure I can get it to show us. Okay, so that is both versions of it, almost exactly the same. All right, so when can you use sine law? There's two different situations. One, you use the sine law if you have the following: two angles and any side. Well, actually, if it says two angles and any side, really what you know is you have actually three angles. Because if you have two, then and you know that the sum of the interior angles of a triangle equals 180, you actually have automatically three. So if they've given you two, you really have three. And often what happens with questions is they often like to fool students by only giving them the two angles. And you need that third angle, and they forget that you could, if you have two, you really have three. The other aspect of it is you need two sides and the angle opposite one of the sides. So in order for it to actually work, you would need to know an angle and the side directly across from it, because then what happens is you would know a side length and an angle, so you would be able to work with this proportion in this way because you would know the top and bottom, and then you could cross multiply. All right, so let's start looking at the examples. Okay, first one says solve angle D. Okay, so I'm interested in D. Okay, and in order to use the sine law, I would need to know a angle, which I do, and the side directly across. So I know this angle and I know the side directly across, so therefore I know I can use the sine law. Now this triangle has D's, E's, and F's, so obviously that's the way I have to put my formula. So I'm going to use the first formula, getting this pen up where I want it to go. So I'm going to write the sine as soon as it lets me do that, which it doesn't want to. Sorry, technical difficulty. Technology is wonderful when it does what you want it to do. Okay, let's start again. See if we can get it to go where we want. Okay, so the sine of F, angle F over side length F, needs to equal the sine of D over D. And I could also put E up. However, I don't know anything about E and I don't know its side length, and I'm not asked to find it, so I'm not even going to write it down. So we have our formula. Now we're going to substitute in what we do know. So we know the sine of 35 degrees over 42 must equal the sine of D, angle D, over its side length, which is 64. Now, I'm assuming that you can follow. I want to find the sine of D, so I'm going to cross multiply. So sine of D equals, okay, I'm going to divide by 42 because I'm going to cross multiply and divide. So in a sense, I think that we're far enough in what we can do mathematically, that we can skip the actual step of cross multiplying. So this is cross multiplying and dividing in one step. So again, because I'm finding an angle, I want to find its ratio. So beautiful arrow there. Not really, I know. So the sine of D equals 0.8740. And that means angle D is going to be the sine inverse of that. Sorry, it's a little bit sloppy side. And we calculate that, remember, to one decimal place, so 60.9 degrees. Okay, so let's look at the next example. Now this one I'm going to use the formula in its upside down version compared to that last example we did, and we'll switch colors. We'll do blue just to add some color to our life. Okay, so this time they asked for me to find side length R. So here's angle R, and here's side length R. Okay, so I'm going to write down my formula, and the reason I can use the sine law is I have an angle on the side directly across. Now my problem is with R, since I want to find it, I would need to know its angle directly across, which it appears I don't. Okay, so this is that example where they've given you two angles and you have to find the third one. Okay, so sometimes you don't recognize it right away, and that's all right if you don't, because you could actually, after you fill out the formula and discover, I need that and I don't have that, you would go back and look. So we know that angle R, and sometimes we can just go angle R and just put a little arrow so the person knows that that's what we're talking about, is 180 minus the other two angles. And when we do that, we end up with 71 degrees. So using our sine law, so little r over the sine of r equals little s over angles, the sine of angle s. Okay, now I'm a real stickler in the sense that I want to see the formula before you enter numbers. Okay, in my opinion, it is the best form. Write down your formula, then substitute in your numbers, then do your calculations. It demonstrates a fair amount of what a person would know. So I'm finding R. We know that angle R is 71 because we took the time to find it. S is 53 and angle S is 83. Again, when I cross multiply and divide, you can see I'm going to be dividing by the sine of 83. So R equals 53 times the sine of 71, beautiful, divided by our sine of 83. And when we take our calculator and punch it in, amazingly, out comes the answer of 50.5. And this time it's meters because we found a side length. Okay, so that gives you a review of the sine law. Next comes the cosine law.